Would you like to know how to use food as medicine for your genes? Get access to my free webinar using the link in the video description. I hope you enjoyed the webinar, and if you do, please make sure to comment and share.
What was shocking to see is that the females started to present ovaries with these vacuoles, okay, that resemble the syndrome of polycystic ovary syndrome in humans. And what was interesting is that the number of females affected by this increased according to the doses that was administered. And the incidence of this disease occurred in the F1 generation, in the F2 generation, and even in the F3 generation. Okay, so this was a transgenerational effect too. Then we investigated other compounds, and honestly, our idea was to find a common marker in the sperm of exposure, but to different compounds. Naively, we were thinking about it. But instead, what we found was this, that none of the epigenetic marks were common across all the different exposures. Now, if you think, well, this is incredible, this is amazing, because this shows that each exposure, each ancestral exposure leaves a particular epigenetic mark that they can identify that ancestral exposure. Okay? So this opens the possibility of collecting a sperm, measuring the epigenome, and knowing if your grandma was exposed to a specific compound. Obviously, this is the theoretical possibility. Okay? Now, the next question was, why are we observing these vacuoles in the ovaries? So what is happening here? So in the ovaries, there's different stages of the follicles. So you have the primordial follicles, the preantral follicles, and the antral follicles. And we wanted to know what follicles were being affected, if any of them were being affected by this treatment. And what we identified is that the main follicles affected were the primordial. So basically, the primordial follicles, as you can see here, go down drastically to about half of their numbers. And this across the treatment. Okay? And not only in the F1 generation, but also in the F3 generation. Okay? So basically, here, these vacuoles that we were observed correlated with the disappearance of primordial follicles. And here is more specific. He's checking as the rats age. Okay, so this is around 1 year of age, and you see that the effects are very drastic. Okay, you see that control animals barely present loss in primordial follicle or polycystic ovary, but all of the compounds presented this phenotype in the F1 and the F3 generation. And it's not a mild change. Basically, it goes for a very small percentage of the population presenting this to almost all the females in the population presenting this phenotype.